everyone, it's Justin again. In this lesson, we're going to learn how to solve proportions. This topic is a continuation of our work with ratios, and it's going to be very important to know for later in this unit, so we can apply it to geometry topics. By the end of this lesson, you will be able to solve for an unknown value in a proportion. First, we'll learn what a proportion is and how it relates to a ratio. Next, we'll learn how to solve for an unknown value in a proportion. Finally, we'll complete an example problem. Let's start by defining proportion. A proportion is an equation where two ratios are equivalent to each other. We learned in the previous lesson that ratios are a comparison of amounts in relation to each other. Here's a ratio, and it happens to be simplified because both 4 and 5 don't have any common factors. What about this ratio? Can this be simplified? Yes, it can. 8 and 10 are both divisible by 2. And if we divide, this would become 4 to 5 as well. This means that these ratios are equivalent to each other and can be written as an equation. Let me show you what I mean. We can write ratios as fractions. So 4 to 5 can be written as 4 over 5. And 8 to 10 can be written as 8 over 10. And just a moment ago, we figured out that these ratios were equivalent to each other. So we can write an equal sign between them. So where does this lead us? What's the point? Well, proportions have some important properties that we can use for solving. For example, there are 4 different multiplication patterns that we can see in this proportion. The first multiplication pattern is going from left to right. In the numerator, we can multiply by 2 to get from the number on the left to the number on the right. And the same is true in the denominator, since 5 times 2 is 10. We can also go from the numbers on the right to the left by multiplying by 1/2, since 8 times 1/2 is 4, and 10 times 1/2 is 5. There's also a multiplication pattern from top to bottom. To get from 4 to 5, we can multiply by 5/4, or 1.25. And the same is true to get from 8 to 10. Can you guess what the final pattern is, or at least which direction we'd be going? Going from bottom to top is the final option. This pattern is not as intuitive for this example as some of the others were, but it does still exist. To get from the numbers in the denominator to the numbers in the numerator, we can multiply by 4 over 5, or 0.8. When there's a variable in the proportion, or just tougher numbers to work with, these multiplication patterns may not be as noticeable. That's what this lesson is about. Being able to solve for a variable in a proportion when we notice a multiplication pattern and when we don't. Most of the time when you have a proportion, one of your ratios will have an unknown value in it, like x in this one. When I say we'll need to solve this, that means we'll have to find the value of x. Many times, solving for a variable in a proportion can be done by using a multiplication pattern, like in the example we just looked at. Here, we can multiply by 2 to get from 3 to 6. As long as we follow that same direction and go from left to right in the numerator, we can multiply by the same number. This tells us that 42 times 2 is equal to 7x. Can you solve this equation? 42 times 2 is 84. Then all you have to do to finish solving it is divide by 7. This gives us the solution for x. So, we found the solution. We know that x is 12 in the problem, but this wasn't necessarily the only pattern we could have used. Remember that there are 4 directions we can use when trying to solve using a multiplication pattern. Left to right, which is the direction we used a moment ago. Right to left. Bottom to top. And top to bottom. Just make sure your arrows aren't pointing in different directions, like this. That would be an incorrect use of a pattern, and it would not help us solve anything. Anyways, even though we've already found the answer, there is another pattern that could have helped us that I want to explore with you. Do you see another multiplication pattern that we could have used? If you see more than one multiplication pattern, which one uses a whole number? We could have gone from bottom to top and multiplied by 14. There is a pattern in each of the two other directions as well. You'll have a chance to explore the other two pattern directions more in your notes template. They're a little tougher because they involve multiplying by numbers that aren't whole numbers, but they can still be done. Anyways, multiplying by 14 gives us 6 times 14 equals 7x. Can you solve this equation and get the same answer for x that we got earlier? When we solve this equation, we get the same solution. It's also a great idea to check your work before finalizing your answer to make sure it's correct. We could take x equals 12 and substitute it back into the equation to see if both sides really are equivalent. Take a moment now to type both sides of this equation into your calculator and see if you get the same simplified form for each fraction. 42 divided by 3 is 14, and 7 times 12 is 84. 84 divided by 6 is also 14. Since both sides of our equation are equal to each other, we can confidently say our answer is in fact x equals 12. Using patterns can be a great way to solve proportions when we need to find an unknown value, and there could be more than one way to do it. But what if you didn't notice a pattern? Would you just be stuck and unable to solve? Of course not. Next, I'll show you a way to solve proportions that will work even when a pattern isn't noticeable. Let's take a look at this proportion. We need to be able to solve a proportion like this for the variable. Do you notice a multiplication pattern from left to right? From right to left? Bottom to top? Or top to bottom? See if you're able to find a multiplication pattern to use here. This time, there's one multiplication pattern that you may have figured out. It was more difficult to find because it wasn't multiplying by a whole number. You may have noticed that getting from 42 to 63 can be done by multiplying by 1.5. If you notice this, you should have used the same pattern in the numerator. You probably wrote down that 5x times 1.5 is equal to 7x plus 3.5. That's absolutely true. And this is one way we can solve for our unknown variable. Take a moment to solve this and see what you get for x. (1.5) times 5x gives us 7.5x. Then we can subtract 7x from both sides, and either multiply by 2 or divide by 0.5 to get that 1x is equal to 7. You're probably wondering what you should do if you didn't notice that pattern. Let's talk about that now. This part of the lesson is super important because if you don't notice a pattern, I don't want you to feel stuck. When solving an equation with fractions, it's a good idea to get rid of the fractions. Let's call that step 1. To get rid of the fractions, we have to multiply both sides of the equation by what's in the denominators. Since 63 is one of our denominators, we can multiply both sides of the equation by 63. We also have 42 in the denominator, so let's multiply both sides of the equation by 42. This may seem like we just made our equation much longer, but do you see any common factors in the numerator and denominator of either fraction? Remember, common factors can cancel, which leads us to step 2. Step 2 is to simplify each side. When fractions are involved, this means canceling common fractions from the numerator and denominator. Did you notice anything that can cancel out from the fraction on the left side? Or anything that can cancel out from the fraction on the right side? On the left side, we can cancel 63 from the numerator and denominator. And on the right side, we can cancel 42. Can you write out what we're left with underneath all this to show your work? It'll help us stay organized and avoid mistakes if we show all of our steps. Take a second to pause the video and do this now. Did you write this down? check your work again to make sure. Now that we have this, solving doesn't look quite as bad. We're used to equations like this from algebra class. Now we can move on to the final step, which is to finish solving. Try to finish solving this on your own. Pause the video now and find a solution for x. Did you distribute to get rid of parentheses and get this equation? Then you likely subtracted 294x from both sides to get here. From there, all that's left is to divide by 21, which gives us x equals 7. Notice that we got the same answer using a multiplication pattern to create an equation, as we did when we didn't use a pattern at all. There will be times when you probably won't notice a pattern to use, so the method we just went through will be super important. And if you're not a fan of looking for patterns, or you find it difficult and not a good use of your time, you can always jump right into our method for solving without a pattern. Here's your chance to try this out by yourself. This example says to solve for the unknown value in the following proportion. Think about the two methods we've learned for solving these, with and without a multiplication pattern. Try each method now and see which works best for the problem. When you're looking for a pattern, you may have noticed that to get from 7 to 13, we could almost multiply times 2, since 7 times 2 is 14, but to get from 7 to 13, we would have to multiply by some fraction. A lot of us may not immediately know what fraction we could multiply by. If you do happen to know how to use multiplication to get from 7 to 13, you may have already used that pattern to set up an equation and solve for x. But let's look at the other option here, without using a pattern. Remember that step 1 was to multiply by the denominators. Did you multiply by 13 on both sides and by 3x minus 10 on both sides? Then, did you follow step 2 and simplify each fraction? That means 13 would cancel out of the numerator and denominator of the first fraction, and the same thing would happen with 3x minus 10 in the second fraction. Now, what do we have left after all that canceling? We have an equation that looks so much more like what we're used to solving. Note that if your factors are written in a different order than mine, like for example, you wrote 7 after the 3x minus 10, that is totally fine. I just rearranged my factors so they'd be more like what we're accustomed to seeing. Now we move on to step 3, and we finish solving. If you got stuck somewhere along the way here and you need a moment to finish this, pause the video and do so now. You should have used distribution to cancel the parentheses. Then, move all the x terms to one side and all the constants to the other. Finally, we divide to get x equals 12. Now, if you did happen to solve this using a pattern to set up an equation, rather than this method, did you also get x equals 12? We should get the same answer either way. If you're curious about what the equation would look like if we used a multiplication pattern to set up an equation instead, ask an adult to see the key for this lesson. More explanation on that is in this lesson's key. Now you can solve for an unknown value in a proportion using two different methods, and determine which method is best. This skill will be really important as our similarity unit continues, so make sure you keep this fresh in your mind. There's also an application problem and some additional opportunities for bonus gold in your notes template. Don't miss out on those, and I will see you next time.